Hello and welcome to the first class on organic chemistry. Today we shall be starting organic, but in the meantime, we have not fixed up the date for test on kinetics, chemical kinetics and electrochemistry. These are the two topics we need to test. Shall we do it together or separately? Mr. Rudrani,
सर गुरुवार दिन काइनेटिक्स को तापरे संडे दिन इलेक्ट्रोकेम्स
गुरुवार दिन टाइम फिक्स करिया।
यस सर गुरुवार दिन सर काइनेटिक्स कि संडे दिन इलेक्ट्रोकेम्स
तो सेपरेटली करिया मो आंसरटा तुमर
यस
आंसर
यस
ସେଇଟା କହୁନ ତାପରେ ଡେଟ୍ ସେପାରେଟଲି କରିବା। ଶ୍ରେୟା, ତୁମେ ତ ଶ୍ରେୟା ଶ୍ରୁତି ତ ୟୁ ଆର୍ appearing all the tests, and so also Saminani, although in her time sometimes it is little delayed. I agree, because you have to prioritize things. That varies from student to student, which is at what time to be done, right? So, କାଇନେଟିକ୍ସ କେବେ କରିବା କହୁଛ?
तो संडे नहीं सर थर्सडे थर्सडे
This I have to rename it.
So Sunday का क्यों?
Yes, I must rename. Sundayটা কি বার? Are you kidding me? Are you kidding me? କଣ ହେଲା? କଣ କହୁଥିଲ ଇଏ?
So Sunday test है.
ସଣ୍ଡେ କରିବା,
Yes.
not Thursday. So Sunday will be a mixed one, or it is a mixed one, or I wanted to change the name. Rename कहाँ नहीं आ रहा है? Okay, so no, I will be making another new one. So, as perhaps the SS sisters propose to have our next test on Sunday, uh, have I heard it correctly? Hello.
Yes.
And what about Saminani? What do you say? Are you keen on appearing the test? Because I have already given you a link in electrochemistry. Also, earlier I gave you a link on chemical kinetics, I guess. Have I?
यस सर
So, a few doubts I think are left uh, for Mr. Rudrani. So, कौन करिवा? So, ଠିକ ଅଛି, ଆମେ ସଣ୍ଡେ ଦିନ କରିବା। ଚାପ୍ଟର ୱାଇଜ୍ କଲେ ବେଟର ହବ। because you have to study deeply for one chapter and appear the test, and then you can have the next Sunday the other chapter, electrochemistry. Mr. Rudrani, please bear with ये परीक्षा तो हबो अब तुरंत
Yes, sir.
अर्थात ऑर्गेनिक चालिबो माने चालिबो. So okay. So before we start, let me, the different classes of haloalkanes is 1 degree. 1 degree are primary. It will be like this. Or the only example of having 3 is methyl halide. These are primary. When the halogen is connected to a primary carbon, either 2 hydrogen minimum or exceptionally 3 hydrogen methyl halide. These are primary halides. And 2 degree secondary halides. Goes without saying that it is prepared from a 2 degree carbon, so it will be left with only 1 hydrogen atom. And tertiary or 3 degree halides, that halogen is substituting a 3 degree carbon. I'll be talking very low voice because very fortunately I have no cough symptom from yesterday afternoon. So there is no hydrogen, so that is 3 degree. Are you writing? I will be, taking pace. Slowly and steadily I will be taking pace. And then I remind you the nomenclature that halo group has no functional group priority. It behaves like as if it is methyl, ethyl, nitro, alkoxy. So these are what I call type A groups: alkoxy, alkyl, alkenyl, alkynyl, phenyl, benzyl, cycloalkyl, all these groups, halo, nitro, alkoxy, these they do not have any priority. They only salute to the, only obey LSL, the lowest or the lower set of locants rule, like other alkyl groups. And the alphabet, then followed by alphabetic seniority, arranging, followed by first LSL, followed by alphabetic seniority. For example, we will not be doing unnecessary small, examples which has no relevance for you. Yes, can you name this compound? I'm taking a monohalo monochloro compound. Can you name this? This is the longest continuous carbon chain. That is the main thing here. Like alkenes, we don't bother, don't honor chlorine, bromine, iodine. We don't honor them. It's not like a double bond. Even we are not honoring double bond, triple bond when we have a longer chain excluding double bond or triple bond. The new rule will honor, no doubt, but as an alkenyl group, monovalent alkenyl, or even if the double bond is directly connected, it will be alkylidene, an idene prefix sorry, suffix will be there to indicate it's a bivalent group, edene. So what's the name? This is the line structure where these Shruti Shreya, feel free to ask me wherever you find out if you really feel little defeated to bother or to ask during the class time, to feeling that you are wasting others' time, you can write to me. I can give you separate time. No worries about it. Can. So Rudrani?
So, sir, type 1 chloro ethanyl octane.
Sathar Basutho. Your analysis is okay, but you are forgetting that only when the yield is not 1, it is 2, 3, then only AN will be there, only the last E will be replaced by il. Propan, 2il, butan, 2il, but
Khalid,
huh?
Khalid,
Autre kuo?
sir, type 1 chloro ethyl octane.
हाँ इथानिल कौन उड़ी इथानिल मेथिल सेटा इल परा वन अछि एथिल मेथिल रो इल रो लोकेंट वन छड़ा आउ किछि हेई परिबनी प्रोपिल रो वन हेई पारे टू हेई पारे जेल वन हबो सेतबेले प्रोपिल खाली प्रोपिल बा उड़िया रे हमें प्रोपाइल बिले कहू किंतु टू हेले इट प्रोपान टू इल व्हाट वी कॉल आइसोप्रोपिल or some people still call one methyl ethyl, one methyl ethyl. So here the longest chain Sriya Shruti is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4,
Oh,
5, 6,
sir,
7.
ଆଉ ଦୁଇଟା ମିଥାଇଲ ଗ୍ରୁପ
1,
ବି
2,
ଅଛି, sir.
3, 4, 5, 6, 7, 8. କ'ଣ କହୁଥିଲ?
Sir, 3,3 ଡାଇମିଥାଇଲ ବି ରହିବ।
ଆଉ ଗୋଟେ ରହିଗଲା ନା ଆଗ 3, 3 ଡାଇମିଥାଇଲ
Yes,
ତାପରେ
sir. ତାପରେ 5 1 chloroethyl octane.
yes. So the longest chain is the norm here. And
ନା
after
sir, ଆଗ ଏଇ କ୍ଲୋରୋ ଗ୍ରୁପଟା ରହିବ ତାପରେ 3,3 ଡାଇମିଥାଇଲ ରହିବ।
yeah, of course, for a complex group, the first letter will be taken into consideration for alphabetical arranging, irrespective of whether it is di, tri, tetra. The D, T will come, will be taken into consideration. The first letter in a complex group. So we have already demarcated our longest chain is this one. And then how to number, start numbering, looking to the LSL, lower set of locants, 1, 2, 3, 3 में आ जाता है. तो अगर हम यहाँ यहीं से शुरू करते हैं 3 में आ जाता है, लेकिन यहीं से शुरू करते हैं 4 में आता है. सो दिस डायरेक्शन इज रॉन्ग. ओ माय गॉड. ओके, कोई बात नहीं. So this direction is correct. 1, 2, 3, 4, 5, 6, 7, 8 longest chain. ଆଉ ଯୋଉପଟେ ଗଲେ ବି 7 ଆସୁଛି. ଏଇପଟୁ ଗଲେ 1, 2, 3, 4, 5, 6, 7. ତେଣୁ this becomes a complex group. And these are the two simple groups hanging on carbon number 3. So 3, 3 dimethyl. I am not arranging. We'll arrange later. And the name of this group hanging on carbon number 5 of the main tree is again you have to make 1 dash, 2 dash. This is a different numbering that you do according to the new rule from one terminal to the other terminal. According to the old rule, the carbon which is directly bonded to the principal carbon chain is numbered 1. But here, both the rules have the same name. because this is the first carbon attached and this is also the terminal carbon. The terminal carbon is one, Shreya Shruti, the one which is bonded only to one carbon. And if it is bonded to more than one carbon, then it is not a terminal carbon, it is an internal carbon. You don't take this carbon as another carbon. I am talking of the branch only, not connecting it to the main trunk of the tree. So, 1, 2. So, in 1, there is another sub branch, chloro. So, the name of this complex branch is 1-chloroethyl. 5, 1-chloro. This one put inside a parenthesis is a different numbering system, belongs to a different numbering system as compared to the one which is outside the bracket or the parenthesis. So 1-chloroethyl. And then C will be taken into consideration. Here di will not be taken into consideration. This is a simple group. For a complex group means having sub-branch. Ethyl, methyl, propyl, these are simple branches. But if there will be sub-branches, or even the locant of eel is not one, propan 2-eel, as we call isopropyl or 1-methyl-ethyl, they are also complex. The eel locant is one and there is no sub-branch, no other sub-branches, then they are called simple methyl, ethyl, propyl, butyl. Otherwise, they are all complex branches and they have to be, by default, they should be put inside square bracket. Sometimes, if they do not carry any locant, I mean number, we don't put it inside square bracket. Like isopropyl, when you are writing isopropyl, adopting this name from the trivial system is so popular for propan 2-eel or 1-methyl ethyl. Then you are not using a parenthesis to put isopropyl. You are you are treating it as if it is a simple group, simple branch. So here we can't do that. So C comes first. So 5, 1-chloroethyl, then 3,3-dimethyl. These are the branches. And then you have octane. Not that you are bound to go in such a direction that chlorine will be directly hanging into the tree. No, it's not a type C group. The type C groups which have their relative priorities, the last one is amino, you can't neglect them. Even if the longest chain is really not longest, it may be a longer, we call a principal carbon chain. We cannot, dishonor them. But others like alkoxy for ethers, like nitro, chloro, phenyl, benzyl, and all these, they are type A groups which do not have any functional group priority. Got it? Understood? Ansul, good morning to you, but you are late.
Good morning.
20 minutes. I think you joined at 5:20. Am I correct?
Yes, sir. That's very good.
You have to be sincere, Baba. Otherwise, organic things, they are all interrelated. Things will slip out. Now, talk something about a bit of isomerism. Because when we deal a particular topic, we deal everything. Although we have done isomerism from A to Z in our class 11 program. But here we are revising isomerism involving haloalkanes. So we can have first structural, if I say, C5H I'm not putting any double bond. 2n plus 1, 2n plus 1, 11 Br. How many structural isomers? And then how many total isomers, including stereo, if at all there is a stereo? How many? First, structural isomers. Two, how many total isomers? To make it more clear for now, including stereoisomers, if any. Achita, if any, God. So how you will proceed? As I've already told you, I'd not like to waste your time or my time. 1, 2, 3, 4, 5. I want that we should finish before. They are my two granddaughters whom I received yesterday. They have tremendous jet lag. So the elder one, just we came at 9:30. We reached here. So she took a shower and straightway went to sleep. I don't know when, if she has woken up in the midnight, because she must have felt hungry, and I don't know. But the younger one was good. I think she had a lot of sleep during her journey, international journey and also the domestic journey. So after shower, she took dinner with me. She took her quota of dinner, and she likes dessert. In dessert, she always prefers laddu. So she took laddu, and then since she had no residual, you know, sleep left to compensate, she started reading a book, and then I don't know when she had gone to sleep. Anyway, so before they wake up, we must finish. Now, there are 5 carbon atoms. So, and bromine is the one which is, so we can put bromine here. This is one. Keeping the 5 carbon atoms in straight chain, we can put bromine here. So 1 bromopentane, 2 bromopentane, and we can have 3 bromopentane. There is no 4 bromo. It will be on the other side, it will be 2. So there will be only 3 isomers, structural isomers, 1 bromo, 2 bromo, and 3 bromo. And then reducing the chain size, putting carbon either in this second or this second. There will be no third second. And then looking for, the non-equivalent positions. This is one, these two are equivalent. You can put anywhere, same. Then keeping that skeleton intact, you keep on changing the position through different non-equivalent positions. Then bromine can be given here. I'm not changing the skeleton. If you change the skeleton, then then I'm putting bromine here, and then finally, oh, I'm so sorry. এইটা গলা আরে আমি তো এইটা ଦେଲେନି ହଁ ଏଇଟା ଦେଲେ ଏଇଟା ତ ଏଇଠି ଆସିବ ନା ନା ତାପରେ ଏଇଠି ଆସିବ. These are the how many? 1, 1, 2, 3, 4. Because these 2 carbon atoms are equivalent. 1, this is another non-equivalent 2, this is another non-equivalent 3, and 4. And of course, if you put hydrogen atom, then you can see whether it carries a chiral center or not. The stereoisomerism is due to enantiomerism. there is no question of any geometrical isomerism or diastereomerism due to double bond. Of course, there are two chiral centers that can be diastereomers even if it is a saturated compound. Am I able to audible? Can you hear me? I am talking very slow
Yes.
voice.
Yes.
Yes, sir.
And here, if you put, then you have to know whether you are missing out any enantiomer. I mean, a- and of course, you have to do everything. Who knows? There might be a carbon not connected to bromine, but still a stereo center. So it's always advisable to put the required number of hydrogen to look for the enantiomers. So, okay, then we still reduce the size with the 3 carbon atoms. We had first given 5 carbon atoms in a chain, then 4 carbon atoms, with the 5th one in the second position, now 3 carbon atoms. The remaining 2 cannot be put as ethyl, then that will repeat 4 carbon atoms that we had already exhausted. Therefore, you have to put the 2 carbon atoms on the same middle carbon. So this is a neopentane skeleton, and all the 4 carbon atoms are equivalent. So you can put bromine anywhere you like. I think you cannot further go down to make 2 carbon atoms as chain and put 3 others. If you do so, you are then repeating the old ones. So these are the how many? 1, 2, 3, 4, 5, 6, 7, 8 structural isomers. Have we left anyone? You can point out. But this is a chiral center. It exists as a DL pair. So because it's bonded to bromo, hydrogen, methyl, and N-propyl. So it's a asymmetric center, chiral center. So I write +1. And this is not a chiral center because these two groups are same. And what about this one? Shreyasruti, is it chiral? Is this molecule chiral or not? Is this molecule chiral or not?
Yes, sir.
Why? Because this carbon is a chiral center bonded to bromomethyl, methyl, and ethyl and hydrogen. So this is also +1. And this is not. Methyl, methyl are same. And what about this one? Is it a chiral molecule? Yes, Sami?
Yes, sir.
No,
Some,
sir.
because this is a chiral center bonded to bromo, methyl, hydrogen, and isopropyl. So +1. And this is not a chiral center, nowhere. And of course, this cannot be a chiral center. So how many? 8 plus how many? 1, 2, 3, 4, 5, 6, 7, 8 plus. How many plus 1 plus 1? 1, 2, Sarita, are you kidding me? 1, 2, 3
Yes,
ତ
sir.
ଗଲୁ 4ଟା କୋଉଠୁ ଆସିଲା?
ଟୋଟାଲ
ହଁ ଟୋଟାଲ କେତେଟା? ଆରେ ଟୋଟାଲ କେତେଟା ରୁଦ୍ରାଣୀ? ନା ଆଉ କିଛି? ହଁ
ଟୋଟାଲ 8ଟା ହେଇଗଲା ଆଉ
ଆଉ ଗୋଟେ ମିସ୍ କଲେ କି? ଆରେ ଆଉ ଗୋଟେ 1 ବ୍ରୋମୋ 2 ବ୍ରୋମୋ 3 ବ୍ରୋମୋ ସେଥିରୁ 2 ବ୍ରୋମୋଟା chiral, then The other skeleton having 4 carbon atoms with the fifth one in the second position. You have 1 bromo, 2 methyl butane. You have 2 bromo, 2 methyl butane. You have 2 bromo, 3 methyl butane. Now see, this is 2 bromo, 2 methyl. This is 1 bromo, 2 methyl. This is 2 bromo, 3 methyl. And this is 1 bromo, 3 methyl. This is 1 bromo, 3 methyl. They're all different. So we have added +1, +1, +1 3 times. So 8 plus 3 kete hobo? Are tell me if I have missed out anyone. Tell me, Rudrani କାହିଁକି ସମୟ ନଷ୍ଟ କରୁଛ? ତମେ ଭାବୁଛ କି ଆଉ କିଛି ଆମେ ମିସ୍ କରିଛେ? କୁହ ତାହେଲେ। ରୁଦ୍ର, are you, is there any, are you able to hear me? Are you able to hear me?
Yes, sir.
ଆରେ ଆମେ ଆଉ କିଛି ମିସ୍ କରିଛେ ନା ଏଇ 11ଟା?
Settings, sir.
ହଁ?
Settings, sir.
Yes. Including stereoisomers. ଯଦି କିଏ ପଚାରିବ how many total isomers, how many isomers, ତାମାନେ ସେ stereo କୁ include କରିବାକୁ କହୁଛି. And there cannot be any cyclic isomer because there is no unsaturation. So total 11. And just to ask another question before we go for preparation. Supposing this compound isopentane or 2-methylbutane, if it is subjected to chlorination, which is highly unselective, unlike bromination, which is highly selective. The chlorination is very fast, so it is not selective. So you get all varieties of. Supposing we control, you take excess of the organic compound and less of chlorine, so we get all monochloro compounds. So how many, this H nu stands for photochemical reaction using sunlight. Then how many chloro compounds you will get? And what are the, how many isomeric monochloro? My question is how many isomeric monochloro compounds can be prepared from isopentane? Isopentane skeleton we can't change. There, while we were studying isomerism, we were changing the skeleton for changing structure. And then we were trying to put the bromo group or halo group at different positions.
So,
Hmm.
so stereo include karibo.
Hmm?
So stereo include karibo answers.
Ketita?
So stereo
Yeah.
isomerism
Of course, Miss Sisters, yes. When I say how many isomeric, it includes stereo.
Sir, total
5.
short as
The sisters, the Misra sisters say 5. Rudrani says 6. Is there any third a dispute? Saminani? Saminani ढूंढो की?
No, sir.
छह ना 5. You be an arbitrator.
So 6 does.
And now they have retracted their own decision and agreed for 6. Great. That should be. Now, these are the two equivalent positions. Let's write down anywhere. These are the two equivalent positions. जोउठी लिखली बेका कथा. This is one monochloro. आगो लिखी दवा केतुटा. Then this is another non-equivalent position. Don't change the skeleton. Then this is another non-equivalent position. And this is another non-equivalent position. So after having written the structural isomers that we are getting, so structural isomers, there will be 1, 2, 3, 4. 1 for these two equivalent positions, 2, 3, 4. But we have to look for any chiral centers. Yes, here is a chiral center connected to chloromethyl, methyl, ethyl, and hydrogen. So +1. And this is not a chiral center. This is a chiral center connected to chloro, hydrogen, methyl, and isopropyl. Just we are doing before a bit. And this is not a chiral center. So 4 plus 2, 6. Got it, Saminani?
Yes, sir.
Answer, you understood, Baba?
Yes, sir.
Okay. And after having a bit of revision, we have to go for the general methods of preparation of haloalkanes. This will be a revision because in hydrocarbons we have done indirectly, not directly, but in the properties of alkanes, from alkanes we know that we have particularly suitable will be chlorine and bromine for photochemical reaction. This should be also thermal reaction. Bromination will need thermal and as well as light both. And the mechanism is free radical substitution. As we write SF, mechanism will operate here. And you will get RCl or RBr, as the case may be, plus HCl or HX. It's restricted to only chlorination and bromination. Fluorination and iodination, they do not have such free radical mechanism. Although we get iodoalkane with much difficulty with taking HiO3 as one of the demons which devour the Hi formed and converts to iodine. Even then, it's not a recommended reaction, as we shall see. The Finkenstein reaction that we will be studying in this chapter will be the most favorite, because the yield will be more here in Finkenstein. And for fluoro also is very, very explosive reaction with alkanes. We do a lot of precautions, dilute we don't take directly, we take cupric fluoride and all that. Fluorination is dangerously explosive, but we have a Schwartz reaction that we study in haloalkanes. It's a very easy way to get haloalkanes from chloro and bromoalkanes, which are produced very easily from alkanes. Now, this, I remind you, the selectivity versus reactivity. Selectivity, bromine is greater than chlorine. Reactivity is the opposite, because Had it been, let us include fluorine and iodine in the fray, but it won't go in the way as chlorination and bromination go by radical mechanism in presence of sunlight. Fluorination is dangerously explosive. Just for the sake of fun and experiment, we get fluorocompound by doing a lot of manipulation from alkene. Also get iodo compound from alkene with a lot of manipulation. But it's slow process, and one is extremely dangerous and fast, the one is very slow. So we avoid getting quantitative amount of iodoalkane and fluoroalkane by this method. And 3-degree reactivity order is always this attack of halogen, because 3-degree free radical is most stable, followed by 2-degree, followed by 1-degree, and then because followed by methyl, because the free radical stability is mostly understood from hyperconjugation structures. Although we can apply plus I effect because it is electron deficient, having 7 electrons, a free radical, but still hyperconjugation is a better choice to explain why 3-degree. So I'm not going to explain the free radical mechanism, which we have done vividly in our class 11 program. And of course, for chlorination, since it is very, very less selective, the 3-degree versus 2-degree versus 1-degree per H atom, it is 5:3.8:1 is very, very, the ratio is very, very close. But if it is bromination, it is so very selective, though slow, per hydrogen atom, the 3-degree versus 2-degree, କିଏ କହିପାରିବ? Rudrani? What will be the ratio? Who can tell me? Saminani? Rudrani?
बहुत ଅଧିକ रेशियो
ହଁ, ଅଧିକ କିଏ ନ ଜାଣୁଛି କି ବ୍ରୋମିନେସନ ମୋର ସିଲେକ୍ଟିଭ କହୁଛେ, ମନେ ଅଛି କାହାର? ସମୀ? ଛେ 1600:82:1. That means when you are having a compound like this, you are carrying out bromination, then almost the exclusive product will be 3-degree, because 3-degree has a 1600 times more probability than 2-degree, than 1-degree, and 1600/82 times more. So if you calculate, taking the probability factor into account here, 9 into 1, 9 into 1, or say 1 3-degree, 1 into 1600 by 9 into 1, then only the two products that you expect, one is isobutyl bromide, the other one is tert-butyl bromide. These are the only two products that you expect from isobutane. So it will be, if you convert to percentage, 1600 by 9, more than kete percent aschi? More than 95%. 1600 by 1609 into 100. Kete hela कहलो देखिवा. So 3-degree product will be
99.44
eh?
99.44
Therefore, bromination is the best choice for any synthetic scheme. You always opt for bromination, because chlorination, supposing you carry out chlorination with the same compound, you will definitely get two compounds. Monochloro. I am not, talking about dichloro, trichloro. There is a huge possibility for chlorination for multiple. But if you take excess of the alkene and less limited chlorine, then monochloro will be there. But there will be two. Sorry. This is one. So tert-butyl chloride and isobutyl chloride will be the two products that you get. लेकिन ब्रोमिनेशन में एक का आइसोब्यूटिल क्लोराइड का नामो निशान मिट जाएगा. दिस इज 1 डिग्री प्रोडक्ट. दिस इज 3 डिग्री प्रोडक्ट. As we have calculated, the exclusive abundance of 3 degree product will make the other product almost non-existent. But here, both of them will be formed in appreciable quantities. Can anyone tell which one is the major product? Raise your hands, please. Rudra, please hold on. Think. I would like to ask maybe others, including Saminani. Shruti Shreya, what do you think? 3 degree product or 1 degree product? No decision. Yes. Yes, Saminani?
The 3 degree.
3 degree product. Rudrani?
The primary.
Precisely. Here, the only place Shreya Shruti on Sulu Saminani will get an exceptional outcome because the probability factor is 9. And per hydrogen basis, it is 5 is to 3.8 is to 1. There is no secondary. So if you calculate 1 degree chloride or say 3 degree, let me write down 1 degree then because it will be more. 1 degree chloride by 3 degree chloride, these are the two isomers that will be formed, is equal to, there are 3 plus 3 plus 3. The probability factor will be 9-fold more to have a monochlorination because we are monochlorinating, no doubt, but the probability factor will be 9 times more because there is only one 3 degree. So ये इसका इसीलिए पल्ला भारी हो जाएगा 9 के लिए. And if it is 1, this will be 1 into 5. So 9 by 5. See, so the percentage of this product will be 9 by 14 into 100. How much it is coming? Miss Rudrani, sorry, Master Rudrani.
64.
64%. Can you imagine? Convincingly, the isobutyl chloride will be in greater yield compared to the remaining will be 36% will be tert butyl. Had it been bromination, isobutyl का नामो निशान मिट जाता है. So that's the beauty. In most cases, you know Shruti Shreya, and you can guess without any calculation. 3 degree product will be more abundant. In chlorinated product, you will get every product. As many number of in isopentane, as we had seen, there are 4 products. You will get all 4 in different yields. Out of which I still think the 3 degree product will be more. Just to have a look. Just out of curiosity, I am saying, only I am considering this 3 degree product. Let's calculate. What will be the percentage? This will be 1 into 5 is to these 6 protons are equivalent. 6 into 1 is to these 2 are again equivalent, but non-equivalent from others. 2 into 3.8 is to these primary, these different from these primary, they are non-equivalent because you get 4 products. 3 into 1. So 5 is to 6 is to, no, still this products is getting more. Co-product अधिक आसुची. तो R percentage भी अधिक आसुनी. ଏଇଟା ଆମେ ପ୍ରଥମେ ରଖିଥିଲେ.
पर ये 6 टा कौन?
हैं?
पर ये 6 टा कौन?
अरे 3 3 6.
सर आओ तीनटा भी तो अच्छी प्राइमरी.
हैं? ଏଇଟା
यस सर.
100 ଥର ବସ୍ ଉଠୁ. ସେଟା ଯଦି ଇକ୍ୱିଭାଲେଣ୍ଟ କରିଦବ ତାହେଲେ ତ 3ଟା ପ୍ରଡକ୍ଟ ହବ. ତାହେଲେ 4ଟା ମୋନୋକ୍ଲୋର ପ୍ରଡକ୍ଟ କେତେ କଥା ଆମେ କରିଲେ ପୁଣି ଷ୍ଟେରିଓ ଆଇସୋମର୍ସ କଥା କରିଲେ.
नाइस सर.
ଆଗ ଜି ସିଂ सो या पाई अलगा कैलकुलेट करवा. ये गोटे प्रोडक्ट दब सिंगल प्रोडक्ट. ये गोटे ऑलरेडी देखुचे यार स्टिल ये डोमिनेंट हैला नहीं. ये 2 डिग्री कार्बन and per hydrogen its ratio is 3.8 and again it is 1 degree into 1. So even then the 2 degree product will be little more. सब गुड़ा कम. Every product will be found will show its beautiful face because chlorination is very less selective. So still 83 degree product हैला नहीं, chlorination product हैला नहीं. No, air percentage कम अच्छी 83 degree product. The only case where you get is in propane. Propane को जो chlorination करिवो, you get 2 products. One is isopropyl chloride and the other one is N-propyl chloride. None is a stereoisomer. So here the 2 degree by 1 degree product will be 2 into 3.8 by 6 into 1. So इसका पल्ला भारी रहेगा. So this is major, this is minor. You got it? Are you following me?
सर
Yes. ପଚାର.
ନାଇଁ ସାର୍ କଣ ପଚାରୁଥିଲି?
ନାଇଁ ବୁଝିଲ ତ ସବୁ?
यस सर.
ମିସ୍ SS अरे बुझिल कि बुझिलनि हो?
Yes, sir.
And I'm sure Saminani must have understood. से भूली जाइछि किंतु से निश्चय बुझिथिबो बिलु. Now Ansul is a good boy but little insincere. If she becomes sincere then ताको केही पारिबेनी. Anyway ଆଉ ଗୋଟିଏ ଯାହା ହଉ ଆଜି ମତେ ଖୁସି ଲାଗୁଛି ଯେ we had made Sri Ganesh beginning of our organic session, and when we study organic in every point it will be starting from the beginning, revising from the beginning and going deep down, delving deep into each point, and then if mechanism is not known, we will also discuss the mechanism. The second one, which is easy, I didn't pick up the preparation from alcohols. That will be very interesting as we have seen. In alcohols, here we will see more as we get haloalkanes using alcohols. There are 2 possibilities. One is simply adding the hydroacids HCl, HBr, HI. HF, the reaction is very slow. The reactivity order is HI greater than HBr. I'm not writing today. We're not studying today. Today I'll be leaving after 5 minutes. I'm feeling just like a thief looking at the police inspecting somewhere. Doesn't matter. These American guys, they have a different culture. So of course their parents have always prioritized on Indian culture. So they also love taking pitha, chakuli pitha and dosa, idli, their favorite snacks and breakfast. He is from Alkenes. Kali kariba, Kali coach. No, we will have. We missed out. We have Tuesday night. ଆମେ ମିସ୍ କିଛି କରିନି। ମୁଁ ଗୋଟେ ଏକ୍ସଟ୍ରା କହୁଥିଲି ତମକୁ ନେବାକୁ ମଣ୍ଡେ ଦିନ, ଆକ୍ଚୁଆଲି ତାଙ୍କ କ୍ଲାସ୍ ଥିଲା। ସେମାନଙ୍କୁ ଆଗ ମନା କରିଦେଲେ। ମୁଁ ଭାବିଲି ତମ ସାଙ୍ଗରେ ବସିଯିବି। କିନ୍ତୁ when I woke up, I came here, then I found, then no, I will not be greedy. କାଶ ଜୋରରେ ହଉଥିଲା। ଯଦି ମୁଁ କାଶ କଣ୍ଟ୍ରୋଲ ନ କରିପାରିବି ତାହେଲେ ମଝିରୁ ଛାଡ଼ିଦେବାକୁ ପଡ଼ିବ, ଲାଭ କ'ଣ? So tomorrow Tuesday, Thursday and Saturday.
Yes, sir.
ହଁ
Yes, Sunday.
ହଁ ସଣ୍ଡେ ବି ଆମେ କରିପାରିବା। ପାଗଲାଟା ତାଙ୍କର ମଣ୍ଡେ ୟେସ୍ ଆଉ ତମର 4 days ହବ because we have to finish as soon as possible so that you will get ample time for revision. You can ask your doubts. We can have some tests Monday, Wednesday and Friday. 3 दिन चालू. Alkenes, they're very simple. They follow the Markovnikov's rule. If it is a simple type of alkene like you have HCl or HBr or HI, so you know this electrophilic addition mechanism we have all discussed in detail. So the only product that you get is this. This is regiospecific. Because the 2-degree carbocation which is formed has convincingly more stability than 1-degree. 1-degree carbocation is never formed. It is fictitious. I mean, it doesn't happen. It is bypassed. We talk to students that 1-degree is the less stable carbocation, but during mechanism, it is bypassed in a single step. Never goes via the formation of 1-degree carbocation. Very rarely they have identified, very rarely with a slow reaction, they have trapped, because these intermediates are real entities, though they are reactive, but they can be trapped by the human manipulation, they can be trapped. But when you don't involve, or the reaction doesn't involve any intermediate, it goes simply via a transition state, higher energy hill, then you can't trap any intermediate. You just have to put forth the mechanism and study the kinetics. If it is second order, where the rate is increasing with increase in concentration of this as well as this, and if 4 times, if this is double, then obviously this is a second order reaction, first order with respect to this and first order with respect to that, and that you can do that. And this is AD. But coming to this is interesting case, since you have acid H plus ion, ये जो कमाल दिखाएगा, क्या होगा प्रोडक्ट बताइए, मेजर प्रोडक्ट क्या होगा कोई बता सकता है क्या? अगर पास में अगर कोई ब्रांचिंग है तो यस,
सर टर्शियरी होगा।
यस, बिकॉज बिकॉज कार्बोकैटायन के थ्रू जाएगा, एडीई मैकेनिज्म थ्रू जाएगा, लेकिन कार्बोकैटायन का जो है खासियत, रीअरेंजमेंट, वो हो जाएगा। सो कार्बोकैटायन यहाँ होगा लेकिन हाइड्राइड शिफ्ट यहाँ होगा। सो आई एम जस्ट showing you in one step, but secondary carbocation is a real entity. Then hydride shift to give a 3D carbocation. Ultimately, a chloride ion will be. I am showing you funnily in one go. So the major product will be a rearranged product. You got haloalkane, no doubt, but not the one which ordinary students will expect, 2-chloro 3-methyl uh, butane without any rearrangement. But chloro doesn't enter into the second position, enters into the, I mean, this position, it enters into this position, 3 degree position because of rearrangement. But AD, but if it is the case of if you want to have of course a free radical, there is a possibility of free radical rearrangement, particularly bromine. Supposing we have once again HBr is added in presence of hydrogen any peroxide, benzoyl peroxide or hydrogen peroxide or ditertiary butyl peroxide. Then this is anti-Markovnikov addition and the mechanism is ADF, free radical mechanism that will operate. And we say that the negative part will be here, positive part will be here, the opposite to Markovnikov. But actually there is no positive, negative. These are all free radicals. But when make a rule, we say the peroxide effect or the anti-Markovnikov addition, the negative part goes to the carbon bearing more number of hydrogen atom, just the opposite of Markovnikov rule. So we get this one by free radical addition mechanism. Any free radical process may it be substitution or addition, you have 3 steps, 3 major steps. Who can tell me what are the 3 major steps involved in a free radical mechanism?
सर फास्ट हबो इनिशिएशन तापरे प्रोपगेशन देन टर्मिनेशन।
Yes, whether it is substitution or addition, you have 3 steps: initiation, propagation, and then finally termination. During termination, so many unexpected peculiar products will be found in very trace quantities. Sometimes you get questions. So mm, at this compound, the mechanism, if you write ADF, the initiation will be HBr. Supposing H2O2, first H2O2 will give you the primary radicals. The primary free radicals will generate the secondary free radicals, as you know, because you have given bromine. This is the primary free radicals produced, which will now, in the propagation step, you take a non-symmetrical alkane, and of course, this will be joining here so that a more stable 3 degree free radical will be formed. Then it will take up another HBr, so that this, sorry, 1 electron shift, so that it will be producing the product and a bromine dot will be let loose to go for a cyclic process. Br dot will no more be required from the initiation step. That is why it is called initiation. A little bit of Br dot is required with the help of peroxide. But once propagation starts, as we call in Odia, ମାଛ ତେଲରେ ମାଛ ଭଜା ହବ. The ତେଲ will be created there in the propagation step Br dot. ସେ ପୁଣି attack କରିବ ପୁଣି ଚାଲିଲା ଗାଡ଼ି ବାଦାମ ବାଡ଼ି. And finally, ଯେତେବେଳେ ସବୁ one of the reactants will be completely exhausted, then ଯୋଉ ଟିକେ ଟିକେ ବଳିଥିବ, so they will undergo different types of combination, disproportionation. So the most important among them, ଦେଖ ଏଠି ଯୋଉ radical ଟା ହେଇଥିଲା, ସିଏ ଆଉ ଗୋଟେ ଯଦି OH ଡଟ୍ କିଛି ମିଳିଥିବ, ଯୋଉ ହାଇଡ୍ରୋଜେନ ପେରୋକ୍ସାଇଡ୍ ଯଦି ନେଇଥିବ, ଇଭେନ୍ Br ଡଟ୍ ଯଦି ମିଳିଥିବ, ତମେ ଏଣେ HBr ପକେଇଛ, କିନ୍ତୁ ଦେଖିଲା ବେଳକୁ ଏ ସ୍ମଲ୍ କ୍ୱାଣ୍ଟିଟି ଅଫ୍ ଭିସିନାଲ ଡାଇବ୍ରୋମାଇଡ୍ ହେଇଯିବ. ଏଇଟା ପରୀକ୍ଷାରେ ପଡ଼ିବ. What are the products which are formed, which can be formed? So you can get a vicinal dibromide, but a little bit, very trace quantity during the termination process. You can also get bromohydrine, because if you are taking hydrogen peroxide, some OH dot will be there. So they will combine to give you a peculiar, as if you have taken HOPR or bromine water. These are the unwanted things which will come up. And a mutual combination, two such, can join. This is called mutual combination to give a very big compound. This is funny. These are meant for questions, and there can be also disproportionation. You can, two of them can go for disproportionation. One can give a hydrogen to make it saturated. The other will be having a double bond. ଆଉ ଗୋଟେ କମ୍ବିନେସନ୍ ଭଳିଆ ଲେଖା ହବ, କିନ୍ତୁ ଆକ୍ଚୁଆଲି ମିଶିବେନି ସେମାନେ. ଏଇଠି ଧର ଗୋଟେ H ଡଟ୍ ପଳେଇଲା, ଏଠି H ଡଟ୍ଟା, ଏଠି CH ହେଇଗଲା, ଏ ଡଟ୍ ଆଉ ଏ ଡଟ୍ ମିଶିକି ଡବଲ ବଣ୍ଡ. ମୁଁ କାହିଁକି, ଏଠି ବି ହେଇପାରିଥାନ୍ତା. So I am giving you a more stable, more branched alkene ମୁଁ ଦଉଛି, ବାସ୍ ଇଏ ବି ହେଇପାରିବ. ପ୍ଲସ୍ an alkane, ଏଇଟା alkane କହୁଛି, ମୁଁ saturated compound ଏଠି ବି ହେଇପାରିବ. There can be so many possible termination products. So this is called disproportionation. One is oxidized, other one is reduced in the organic parlance. So we have discussed how haloalkanes can be produced from alkanes and alkenes. In alkenes, if you are directly adding HCl, HBr, HI without anything, then you must look for a probable rearranged product if there is a side substitution somewhere. But if it is only HBr, because the peroxide effect is only applicable to HBr among HX, not applicable to HCl and HBr. Even if you have a peroxide, it will go for it will go for Markovnikov addition. Peroxide has no role to play, because it has been found out, as I told you, that the free energy change is only negative for HBr, because qualitatively the bond is neither highly polar like HCl nor highly polarizable like HI. I minus has the biggest size, highly polarizable. and HCl is highly polar. HBr, is intermediate, enjoys a appreciable polarity, not very high polarity like HCl. And the polarizability is also not very high like I minus. So it is the perfect bond for interacting with the OH dot, the primary free radical from a peroxide molecule, whether it is hydroxide free radical or any other alkoxy free radical that is produced from any peroxide. That brings about homolytic cleavage of the HBr bond. The HCl and HI bond, they are susceptible for heterolytic cleavage, even if there is a primary free radical OH dot. It doesn't favor homolytic cleavage to produce free radicals. Guys, enough of enjoyment that we have made. ଶୋଇପଡ଼ ପୁଣି ଘଣ୍ଟା 2 ଘଣ୍ଟା ପରେ ଉଠିବ ଯଦି ସ୍କୁଲ ନଥାଏ. ବାଏ ବାଏ. We'll see you on Thursday. Bye. ଖାତା ଆରମ୍ଭ କରିଦିଅ. ମୁଁ ଆଜି କିଛି ନୋଟ୍ସ ଦଉନି, ସୋ ଦେବି ପରେ. ସେଦିନ ମୁଁ ମୋର ପାୱାର ପଏଣ୍ଟ ସ୍ଲାଇଡ୍ ଦେବି, ସରି PPT ଫାଇଲ୍ ଦେବି, ତା ଛଡ଼ା ଅନ୍ୟ ଫାଇଲ୍ ମଧ୍ୟ ଦେବି. ବାଏ ବାଏ.
प्रणाम
Thank you,
सर।
sir.
Thank you, sir.
So.